So, welcome everybody, and we'd like to extend a warm welcome to Matthew Adams, who's here today. Very pleased that you've come to visit us, come to speak to us about your work. And we've known Matt for quite a few years, actually. I say we, but several colleagues in our research centre. And I could say, Matt, that you kind of almost dedicated your professional life to trying to explore and understand and promote this crucial link between soil health, plant health and human health, which is the basic tenet of the alternative farming movement, I need to say as well. And with that, you know, that's the underlying philosophy of the organic farming and biodynamic farming and other forms of alternative agriculture, upon which then we need to have equality and equal access to stuff. But the basic tenet is health. And I think you were running a charity on the Good Gardeners Association, which had been going since 1966, and you were doing some research through that, and then now you're going to talk about your more recent research through your initiative called Growing Real Food from Nutrition. So thank you, Matthew. Take it away, and then we'll have Q&A afterwards. Thank you.
Thank you, and thank you for inviting me. It's a great pleasure to be here. And I'll try and think about time. But so let's just kick off with this. And I'm sort of guessing most of you will be familiar with that picture. It's expressing the quality of a potato in a picture, and it comes out of the biodynamic movement. Hybrid 5-foot developed the circular chromatography method. It's expressing the whole composition of nutrition we find in a plant in a picture, and you can actually read these. Oh, okay.
I think it's sharing it with the people online, is it?
Hopefully, can everyone see the slides online?
Yeah, we can see the slides now.
Thank you.
Right.
Okay.
Thanks, Rachel. And so I'm not going to go into too much detail, but you can read zones of information from the centre, the touch screen.
Oh, yeah, don't touch it. Yeah.
And then the next circle out, and then the next circle out, and then the periphery. So there's kind of 4 zones of information in there relating to minerals, vitamins, enzymes, and it's all being shown in one picture. And what I love about this picture is that it goes so well with this quote by von Goethe, that the whole is more than the sum of its total parts. And I think this is where we're essentially at. You cannot look in isolation at the individual bits. You need to look at it as a whole picture. So, I don't know.
Yeah.
And so I've been looking at this, as Julia said, for a long, long time. And actually, what I'm also going to say is one of my inspirations is the deep green philosophy known as deep ecology, which questions worldview. So in my attempt at questioning worldview, I have found myself exploring this soil-plant health connection and how we as society, researchers, food citizens, how we think about that. So I'm actually a mechanical engineer by trade, so I come from a practical background, hands, skills. And then I left that to do a degree at the new University of the West of England called Environmental Quality and Resource Management, which was a holistic degree looking at all, going through all the different faculties. And I honed in on soil, nature, and the philosophy known as deep ecology. So, so when I took over the Good Gardeners Association, it was the year 2000, and the Good Gardeners promoted no-dig organic compost gardening, and that's what they've been doing since 1966. So they had a good pedigree, a good history, and I spent 11 years running that charity. And within the organisation, people were already getting interested in this relationship between quality of the plants based on its nutrition and the idea of not digging the soil So it was beginning to build this relationship between soil and food quality. So I'll talk about that in a bit more, because I've got a slide about the project that I did with the Biodynamic Association for 8 years. But since then, I had a pause, I had a gap, I became a craft cider maker, a woodworker, and then I came back into the soil and this relationship with food quality in 2018, because I heard about the development of what's called a bionutrient meter being developed in America, and that rekindled my interest to get back into this area. So in 2020, I established GrFFN, Growing Real Food for Nutrition, as a community interest company, and developed citizen science projects to explore food quality. And what I'm trying to do is create now a membership platform and to engage growers in recording quality measurements, entering it into a database, and that database will become the basis of creating a food quality standard database, but it needs to be verified through research. And so that's an ongoing process where I want people to join, and we don't know the answers. We're carrying out research to see if we can validate the identification of food quality and its relationship to soil. So these are just some examples of the projects I've developed and run. So kicking off in 2021 with a growers project in the UK, and then in 2022 we ended up connecting with the Andhra Pradesh community of natural farmers in India, and they were around about 600,000 farmers practicing natural farming. In 2023, I did a big project in Wales around public procurement using locally sourced food. And so the food was coming from local suppliers into a hub to then go out to hospitals and schools and whatnot. So I was measuring the quality of the food that was coming in from the local growers, which has given me an idea of how to create a food quality standard database. And then 22 to 24, a bigger project with the Bionutrient Food Association to contribute to the development of the bionutrient meter. Okay, so general questions: what is food quality? Is it more than the sum total of physical nutrients it contains? And if so, how can it be measured or experienced? And these are just the methods that I've used along the way to measure food quality. So with the Brix refractometer that measures total dissolved solids, to the circular chromatography, to the spectrometer, and at the moment, I'm a big believer in the power of taste as a way of identifying high and low food quality. So I need to just build up my platform here. I mentioned that I'm inspired by deep ecology, which was first articulated in the 1970s by Dr. Arne Næss, a philosopher. And at the beginning of the process of sustainable development at the World Economic Forum in Sweden in '72, he articulated a philosophy of approaching what was perceived as an environmental problem. So as the whole United Nations came together to discuss sustainable development and had their fixed ideas of how to deal with it, Arne Næss interjected with a philosophy called deep ecology to suggest that there's a distinction between what he called shallow ecology and deep ecology. And so shallow ecology is where we're at today, which is is more concerned about policies and economics than it is with actually being a true partner with nature. And he argued that we need to question our dominant worldview in order to realize an alternative one, which is that we are interconnected with nature, and therefore what we do to nature, we do to ourselves. So if we harm nature, we harm ourselves. And I think that evidence is beginning to emerge quite clearly now. And so this is my picture vision of that philosophy in relation to how we grow plants. There's many ways to grow the same plant. And on the left, we've got the result of cheap food policy and the development of reductionist science looking at plant growth. So here we have the aim of growing food for cash. And that is the focus. And so that's led us since the 1800s and the development of NPK as a plant growth promoter. We've now got the accountant injecting the plants with NPK, and there's no life in the soil. And in order to grow a cash crop to earn somebody some money, that's led to industrial pollution. Oh, we got industrial pollution of a large scale and the increase of ill health, and particularly degenerative diseases that's going on in the world. So what I'm relating here is a philosophy with a physical outcome that's depleting environmental health. And on the right-hand side, we've got where we want to get to. So deep ecology is about questioning the worldview that's created this. And where we want to get to is to celebrate our interconnected relationship with nature, which is about symbiosis. So here we've got people joining together to help each other to nurture the life in the soil, because we now want to grow food for health, and we are connecting ourselves into nature. So this is coming much more from the heart. And here's my schematic of the worldview. So it starts with an ultimate premise, and everybody has an ultimate premise. It's our ingrained vision, or what we tell ourselves about how the world works, which then forms a worldview. And the dominant worldview that's been around for the last 400 years is what we call human-centered. The thinking tends to come from the brain, that I think, therefore I am, and we know a bit about the history of that philosophy emerging. And so we create a belief system. We believe that the world is a machine, that there's a mechanistic machine. And in that thinking, we've stripped away the notion of any life in the world. So we've now got a mechanistic way of thinking. Well, when you've got a machine, you start to examine the parts of the machine. So in examining the parts of the machine, you go down into reductionism, because you're looking at a part. But let's, for example, say you're looking at the wheel nut of a car, and you're looking at it so closely and intensely, you don't realize that the wheel nut's coming off the car. And then suddenly the wheel nut comes off, the wheel wings away, and the car crashes. And you think, oh my gosh, I didn't realize there was a car behind that wheel nut. And that is an example of reductionist thinking. But what happens is we teach these values in school and universities, which reinforces the belief. And we've now come to our values that we see nature as competition, red in tooth and claw, and we're trying to control the machine. It's an inherent quality of human-centered thinking. And then when that's taught to the next generation, it reinforces our belief, our worldview. And so you go around in a circular fashion until that expression, you're in the belly of the beast. You're trying to work out how to solve something, but you're beset with an inherited worldview. And in this worldview, food quality is considered by wealth. So here we are here. And so questioning this, we need to move to a non-human centered worldview, and we sense our relationship with the world. We come thinking from a different part of the body, from the heart and all the cells that make up a living organism. And we start to consider the idea that there is a life force in the universe. And that starts to open up our thinking into a more holistic thinking. So now we're seeing the whole car and all the wheels and the nuts and the engine and the seats and everything else, wondering, to work out how it all fits together. And then following on with that belief, we then realize that the world works through symbiosis. I think it's kind of well established now that symbiosis is actually how life has evolved, right from the very first single-celled organisms. And so that moves into symbiosis. So the aim now of the non-human centered worldview is to think about these qualities to make that normal in our life. And if we focus on food quality as health, you begin to realize some of these value systems involved in a non-human centered way of thinking. So the power of a dominant worldview. Deep ecologists have described this as a mental image of social reality that guides expectations in a society. So when we put forward a suggestion, if it meets our ultimate premise and worldview, which is that of the machine, then we tend to think that's okay, and society normalizes that action. So we know that there's a problem going on with food quality and soil health, and the response, the reductionist response, is to think about biofortification. So instead of looking at root cause and maybe the problem with the soil and our relationship with it, the thinking here, the philosophy here is, well, we've now got this with controlling nature. We've now got this understanding of genetics. We can maybe tweak things. We can maybe introduce additional nutrients to make up for that which we're losing. And so, I mean, this just popped into my email box yesterday, and accelerating the action on micronutrient deficiencies. So these large companies, they talk the talk, but really, come back to my picture, it's all coming from a need to create an economic benefit for somebody. And so understanding worldview means you can spot very quickly a worldview that is not really contributing to the overall health and well-being of society, humanity, and the planet. You can tell that just by the worldview. And then here's another example, the race for global food security, and I've crossed this out and put my amendments on. So a 3-10 session will explore reductionist, science-based solutions to the challenges posed by a human-centric worldview. It's got nothing to do with nature. It's only got to do with the philosophy of humans and their reductionist thinking. And this is how that thinking evolves. So back in the 19th century, in the UK, we had the repeal of the corn laws to open up a free market strategy. This is all about economics. And so that allowed cheaper imports to come in, and the market was then able to offer cheap food to those people that, so say, couldn't afford it. And then during the 20th century, more policies came in: urbanization, industrialization, Great Depression, and World War II. These all had the effect of believing we were short of food and we needed to create food security. And so that supported the evolution of cheap food policies. And now, today in the 21st century, we're now into biofortification to rectify the problems created by cheap food policy. So it's in a circular loop that's not going anywhere. So the impact of a cheap food policy through a human-centric worldview, yes, people are spending less on their food, from 1/3 to 11% of their annual income, which means actually they've got more food to spend on more money to spend on consumerism, which creates the problem of what we're calling sustainable development. But along with cheap food policy, who's benefiting? So the impact of farmers' real income is hardly risen in 50 years. And what we know is that we've lost the biodiversity of the soil, considered to be one of the most global, biggest global threats. Since the 1930s, we believe the UK food chain has lost on average 40% of its key minerals, which is related to the loss of soil health. And we're now seeing unhealthy food costing disproportionate amounts of money. So the costs are being externalized for the damage that's being done through pursuing a cheap food policy. Okay, so this is the impact of a human-centric worldview. We know about sustainable development and all the issues associated with that, and they're not going away. In fact, they're getting worse. And the attempt by the United Nations, that's come out a bit funny. So 12% of SDGs are currently on track, that's all, 12%, and 30% stalled have gone into reverse. And that's a quote from the United Nations to summarize how effective sustainable development is. And of course, because this is locked into a human-centric worldview, there is no way out. That we need to go over here to find solutions. So a switch from health, not wealth, is where we're moving towards, to question this worldview and usher in a new one. And so these quotes are just pointing to people in our history that have talked about problem really with our way of thinking. So we can see all these problems as physical problems, but if they all stem from our consciousness and our thinking, it's our thinking that we need to make the biggest change. I'm not going to repeat them, you can read them, otherwise you hear my voice too much. Oh, damn. Right, I'll get used to this screen in a bit. So in summary of all that, what I'm saying is we've got the Sustainable Development Goals here, all 17 of them, developed by all the countries, the United Nations. And this is their best effort at how to deal with the perceived environmental crisis. And it's rather two-dimensional. It's all about things that are wrong with the environment. And now, in the last few years, we've had the recognition that the Sustainable Development Goals are not working, and that we need to consider inner development goals. So the change now needs to come from us. And that's what this is reflecting, is that when we change and our inner relationship with nature changes, then we can begin to move beyond the issues of sustainable development. And you're probably familiar with Conscious Food Systems Alliance. This is one initiative that's come out of this, inspired by the development of the inner development goals. So Conscious Food Systems Alliance are advocating a consciousness practice in agriculture as a way forward. And so this is now a reference now to the fact that at the moment, food quality is measured by profit. And what we've had come out of that is conventional agriculture, genetic modification, hydroponics. These are technological solutions to an environmental problem that's caused the loss of biodiversity, soil fertility, and climate change, and malnutrition, degenerative disease, viruses. Whilst those technologies are in place, the whole health of the world is depleting. But if we could create a food quality standard and say, no, all food must be of, what happened there? All food, if we understood what food quality was and we could set a standard, then you could do what I call pull quality through the food supply chain so that it meets this new standard. And if that new standard is based on creating ecosystem health, then what you do is you affect all food supply to meet this new standard. Otherwise, why do we want it? Because if it's depleting environmental health in its production and it's reducing human health in its consumption, it's a no-brainer. So this is now the idea behind creating a food quality standard database. But the problem now is, what is food quality and how can you measure it? So this goes back to my original research with the Good Gardeners Association. We had a garden in Stroud, partnered with the Biodynamic Agricultural Association and the Hiram Trust, which was August Gordon, and they promote experiential education. And so bringing those three partners together, I developed and designed the research here in the garden, which had 4 plots to look at the relationship between soil cultivation and food quality. So we had a control, we had a no dig, a single dig, and a double dig plot, all growing the same crops. And I measured 23 minerals and trace minerals in the soil, and I measured the same minerals and trace minerals in the crops. Alongside that, I measured soil health indicators of biology and fungi, and was exploring and asking the general question, what is food quality and how can we measure it? So that went on for 8 years. And it's very complex, but this is really summarizing and condensing all that information into this one page. So potatoes is one of our target crops. And what happened over the course of 8 years in a biodynamically certified garden is that the mineral content went from 50,000 parts per million down to just over 20,000. So we lost over half of the minerals and trace minerals in the content of those potatoes over 8 years in a biodynamically certified garden. So what went wrong? So when you look at the chemistry of the soil, the pH, the NPK fertilizer index, nothing very much changed. So if you were monitoring your soil productivity on those parameters, you wouldn't have noticed a drop in the mineral and trace mineral content of potatoes. But if you were measuring the soil biology, you might notice something going on. So the bacteria, fungi was measured, and you can see this now, starting to see this relationship between a loss of soil biology and the loss of nutrients coming up into the potatoes. And as I say, this is very complex, and I've summarized it into these 3 graphs. But when you look behind at all the figures and the data, it's extremely complex, because if you're looking at 23 minerals and trace minerals, how do you know which is good and which is not good? And so now we're back to the circular chromatograms of those potatoes, and we can see here at the beginning of the project, there was a nice picture representing the quality of the potato in year 1. But come year 8, the quality of that potato had all been lost. So you can see that there wasn't much expression of nutrition, because this is what we're measuring here, or vitality going on in that potato in 2011. And this is the same method applied to soil. So we see a vibrant picture of soil health relating to the biology there, and then it all closes in. The life is more condensed and it's not as expressive. And so we're seeing all this complexity in these pictures, which gives a good overview of what might be going on. Now, the only explanation I can give as to what happened was a change in head grower. And so we had a change in 2006, where the original head grower left us, and we took on a new one who had more science experience than growing experience. And it may be that it was related to that head grower taking over. So if it was, that brings humans into the equation of food quality. So I'm not saying that's what happened, but I've always found that a very interesting thing to consider. It might be the explanation of green fingered.
Were they still using the biodynamic?
Yes, it was all certified every year. So you know, according to the rules, it was all being done according to the rules. So this is now moving into the Brix refractometer. So this is now another way of looking for assessing quality. It measures the total dissolved solids in plant juice, and it indicates photosynthetic efficiency and nutrient production. So all the products of photosynthesis that dissolve in water are measured in one simple Brix measurement. And these are some of the nutrients and compounds that you find in a plant that will dissolve in water. And so it begins its life making sugar, and from that sugar uses that as building blocks to build out all these other nutrients into different, to be used for different things. And down here we've got root exudates. So I believe up to 40% of the production of carbohydrate is used by the plant to make into microbial food and push that back out through the root system. So when microbes have a food source, like any organism, if you have an abundance of food, you eat, you grow, and your population increases. And so the plant is building all these nutrients from its base of sugar, and with the supply of root exudates, the populations of microbes in the soil are allowed to increase because they've got a food source, and pull in, because there's more of them, they can access more nutrients and bring that back to the plant in symbiosis, and in return they get fed sugar. So that's my explanation of the Brix refractometer. So it's an indicator. And in the 1970s, Dr. Kerry Reams in America, who spent his life researching soil, he ran a large agricultural laboratory in Ohio. And on his retirement, he came up with what he called the Brix tables of food quality and related Brix values to 4 qualities: poor, average, good, and excellent. And he suggested that when you get excellent values for these crops, you will see a plant that's resistant to pest and disease, has increased yields, has a better taste, and longer shelf life. And I think what he was doing there as well was describing what plant quality is. These are useful metrics to assess what plant quality is. So that's been around since the 70s. Oh, I'm going to give you a demonstration now. This is my moment of fame following the Oxford Real Farming Conference in 2020 or 21. I was invited onto the Radio 4 Today programme, and live in the studio, I did a Brix test and a taste testing with the 2 presenters, Michelle Hussain and Simon Jack. So this will give you an idea.
We're going to do these 2 carrots, which are different. Simon and I are going to test it. So
not all carrots are the same.
They're not the same, no. Let's forget the labels. Let's look at what the nutritional value is.
Okay, so I've tasted sample 1.
So sample 1. So I could very quickly test that. At the moment, the tester that I have to cut a slice of carrot, and then I crush it in my pliers, and I put just a few drops of liquid onto the handheld refractometer, close the lid, and there we go. Within about a minute, I'm now taking a reading, and this reading is, I've got a score of 6.
I like sample 2 better. It tastes better to me.
Simon, okay, let's go with that. So, sample 2 scored a 9, and sample 1 scored a 6.
Is an organic carrot always more nutritious?
There's no guarantee, I'm afraid.
Really?
Could you ever see this at a point of sale? Would I be able to test the carrots in the shop?
Yes, that's what we'd like to move towards. So the evolution of the Brix testing, which is quite basic and crude, is that we're developing a scanner. It's called the bionutrient meter. It's been developed in America, and we'd love to bring it to the UK to contribute to the research. It's an open source project, so it's a project that's in development, and we'll be asking people to get involved with either doing the Brix testing, or the next stage is with the bionutrient meter to be sending us samples so we can find out exactly what's in the food, match that to the scan, and then people can scan the quality.
I'm so shy with that.
Well, we're going to do
So Brix and resistance to pests and disease. Professor Thomas Dijkstra, he's done a lot of testing the relationship between the Brix value of a leaf and the incidence of pests and disease. So he's an entomologist, and this is what he's come up with, which is a chart of Brix values in relationship to pests and diseases. And so what he can talk about with the with chewing insects and things is that when a plant has a higher ratio of carbohydrate, so basic sugars, the insects that eat it, their guts basically explode from an overload of sugar. And so when you've got a high Brix plant, it's producing more carbohydrate, which relates to more other nutrients, but that high level of sugar is enough to explode the guts of these insects. And so here's his relationship to the aphid group. If you've got 6 to 8 Brix and above, you won't get a problem with aphids. So it reaches the magic figure of 12. And so when you get a Brix value of 12 on your leaf or above, he's saying, well, this is now fit for human consumption, because that plant is so well grown. It's full of all the nutrition that's come through that symbiotic relationship with the soil. And you start to see plants that are totally resistant to pests and diseases. It includes protection through the root zone, because the biology is now so abundant in the root zone that viruses and pathogens can't move through that. And so it starts to create a whole vision of health. Below the 12, and it's this I find interesting. So he's been testing GMs and saying that they never get a leaf. He's never found a leaf Brix above 10, and that they're currently applying so much pesticide and herbicides to the crops that they're growing that it's almost becoming uneconomical because of the high input costs. And of course, this is human-centered thinking over here. So those are some of the ideas. Now, putting this into practice, is there a relationship between Brix, pest and disease, taste, da-di-da-di-da? So this is now the work that I did in 2022 with the Andhra Pradesh community of natural farmers. And I taught the health and nutrition team how to do a Brix test, and they went out to the farms and started Brix testing. So in Andhra Pradesh, we've got 6 million farms in total. I'm going to speak about today. The figures today, 1 million are now natural farmers and 5 million are chemical farmers. And the average plot size is 2.5 acres. So what you've got is a mosaic of chemical alongside naturally farmed methods, which is a brilliant testing ground, laboratory ground for citizen science to cover the ground. And so this graph here, across 16 crops, everything that was naturally farmed had the higher Brix value compared to the chemically farmed. And down here, when we moved into taste testing, everything, this is across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 districts in Andhra Pradesh. So that's a diversity of different soils and climates. Everything that we tested and tasted that was naturally farmed, it had the higher Brix value and it had the most number of taste preferences. So it's starting to indicate a way of possibly measuring food quality using the Brix. This is now, this relates to the bionutrient meter, and I'm now looking at actually measuring the nutrients in the crops. So these are the nutrients that are being measured. So we've got 5 minerals, the Brix, antioxidants, and polyphenols. And this is a citizen science project that began in America, and then I imported that method to the UK and ran my own project in the UK. So I used their method so that I could share the values in their database. So I was testing wheat, kale, carrots, and beetroot, and I invited growers from around the UK to send samples of these, plus the soils they were grown in, and they went to the James Hutton Institute in Scotland for the analysis. And so then that gives us the results for the content of these nutrients, and the growers would also fill out how it was grown and a bit of background data. So we're now building out this profile. And these lines here are now expressing where the percentile is in UK crops compared to the US crops. And I was quite surprised by this, because what we're looking at is when you add up the total of all these nutrients, and let's call that now nutrient density, is the total number of nutrients in the crops. And these are all worked out by a percentile to give us now an overall percentile. So, so we can see beetroot is in the bottom 6th percentile, and this is now comparing UK crops to US crops. And then, so that's going 23, 34, 45, 50. So, you know, it sort of plateaus at about 50%. So the nutrient content of crops in the UK generally lower than the nutrient content of crops in the US. So this is what makes the problem of defining food quality by its nutrient composition. How do you know that? You know, how do you calibrate a machine to say, well, if it's in the top 80 percentile, let's call that excellent? Because if you did that, it might work in the US, but if you brought that to the UK, everything would not meet the new standard. So that, for me, raises questions about how we define nutrient density. And I'm beginning to go off the term nutrient density, or say why in a minute. So
the difference between the samples 1 to 12.
So these are the number of samples that I tested in the UK. So the total, well, 12 carrot samples, 11 beetroot samples, and these are compared against about 300 samples from the US. So from those 300 samples, everything gets a percentile ranking, and that's what this graph is expressing.
Do we know what kind of farms or gardens in the US they came from?
That is a good question, because Dan Kittredge, if you know him, he's a progressive grower, and his network is full of progressive growers. So it might be slightly skewed from the fact that the people that joined in that project in the US may actually be already high-level top growers that are producing some amazing results.
But you know who's joined in the UK?
I know everybody in the
Are
UK.
they progressive?
Not everybody, but most of them.
So the one that's called sample one, which has the highest nutrient density.
Yeah.
Can you tell us a bit about their way of doing things?
I can, and I'll get to that in my next slide. So this is now a summary of what we were finding in those samples. So I'll start with the variation range first of all. So you can see that when you start measuring the nutrients, the values from the lowest value to the highest value becomes very large. And you can point to antioxidants and carrot and say, well, that's a huge range of variation. The problem is in understanding it as a whole thing is how does that value of that antioxidant relate to the values of all the polyphenols? And how does that relate to all the values of the minerals? So it becomes very difficult to know the relationship between them. You can pick out these variations, but how does that relate to another nutrient? So these are all the number ones in that graph, and I've called them, so these are the number of UK samples, and the highest value, that's the number ones for all those 4 crops, was a conventionally grown wheat. And the highest beetroot was non-organic supermarket. So, and the highest carrots, non-organic supermarket. So what is going on? And then kale, organic. But at the bottom end of the UK samples, the lowest was also conventional, and the lowest was also organic, and the lowest was biodynamic, and the lowest was organic. So it's not a clear-cut action. Labels that we give to food production systems are not correlating to their inherent nutritional qualities. And so now what I've done, because I've cross-referenced my data to the US database, we've got 239 samples, and the highest wheat came from Syngenta SY69998, a lovely name for a plant, isn't it? But it starts to ring alarm bells about this issue of nutrient density. And so my summary there, this is a quote from Dan Kittredge, who kicked off about the whole research around this, is that our labels do not correlate to the inherent nutritional quality of the crops. And this is now why I'm interested in what is food quality, how to measure it, because that should become the actual measure of all these systems. It's like, get rid of the labels. We just want to know, are you creating high quality food that creates ecosystem health? And this is just a bit more detail about those results for wheat. So again, this is showing percentiles here. And these are the UK crops, ranked 88 to 236. And this is the highest value in the database. And this is the lowest value in the database. So the way I've sort of organized this graph is to try and consolidate all the mineral elements into just one bar. And you can see over here, this is our Syngenta wheat. It has the highest value of polyphenols, the highest value of antioxidants, the highest values of all the minerals, and the highest value of protein. And I look at that and I think, what's wrong with that? Because I question the thinking behind the science that's given us that.
Well, that might be so for 1 and 2 for you. if you tried to continue, but then are they terminators, so you have to keep buying?
Actually, I don't know if they're terminators. That's a good question.
Anyway,
Yeah.
maybe over a few years that those values might decrease as it
Yeah.
regenerates.
Yeah. Well, there's again another problem with measuring food quality. You've got one season compared to the next. Could be a totally different story. So this is highlighting the fact that really this could be a result of human-centric thinking. Let's pump it full of nutrients and make it as good as we can. And and then just another example. So the World Health Organization have identified globally there's over 2 billion people with micronutrient deficiency, and they've targeted iron, zinc, folic acid, and vitamin A. And now what you're seeing is all these high-tech companies trying to fortify their foods with one or more of those nutrients, like golden lettuce. But does that represent quality? Does that create ecosystem health? This is from Journal of Ornithological Medicine, and I've always been inspired by this concept that actually what is a plant doing with the nutrients that it accumulates, and what this is pointing to is the way a plant creates equilibrium. So what it's saying is that if you increase calcium in a plant, that affects 2 more mineral elements, and those 2 more mineral elements affect 2 more mineral elements, and so soon you get an exponential rise. The plants constantly balancing that complexity based on, I believe, the soil, the environment, the grower, all these factors, all these variables come into play, and the plant is master of balance. So actually what I'm starting to think is that nutrient density is the wrong way of thinking about food quality, because we're seeing the fortification of food, which is a human-centric way of thinking. And so actually, maybe it's the balance of nutrients that becomes important. It needs to be in a ratio that expresses ecosystem health. And I'm positing this idea that if a plant is able to balance all those nutrients, is there a life force within that plant that is assisting in that balance? So that's now an open question. Building blocks of nutrition, just to pop through that. But when you break it down, everything we call nutrients is pretty much made up of 6 chemical elements. So how does a plant know how to mix all those chemical elements into all these other compounds that we call nutrients? And there could be, 20,000 discrete nutrients, when you take into account all the phytonutrients. And of course, it requires more minerals and trace minerals to create enzymatic reactions that helps produce all these different compounds. But there's an intelligence going on, I believe, that actually helps to support that process. So what we're looking at, I believe plant quality could be our best indicator of soil health. And at the moment, there's such a big focus on soil health. But if we don't understand what plant quality is, how can you create indicators of soil health? So this comes from the 2020 FAO report on the sustainability of soils. And yes, we're recognizing the importance of soil biology, but there are no meaningful metrics by which soil biodiversity can be measured and assessed. This must be decided upon. So I'm beginning to think, if we understood what food quality is and how that relates to soil health, you could monitor soil health by the quality of the food. And if that food quality made the planet healthier and humans healthier, then you'd be creating this symbiotic relationship. So this has led me to my hypothesis, which I'm quite chuffed about. It's inspired in part by Dr. Fred Provenza's work in why do animals and plants in the wild tend not to get sick. So how can they self-select what they need to maintain health and balance? And what he found was the animals create an internal database through the gut microbiome. So every time it eats something, the gut microbiome is sensing all the nutrients inside that food and storing that as a memory. And when the animal needs a particular nutrient, it's the gut microbes telling the brain what to do about food choices. So I'm now transposing that to humans. I believe humans have this same innate ability to detect healthy, nutrient-rich food that creates ecosystem health. And if I can, if I can demonstrate that, then you can then ask the question: why aren't we using our senses in this way? I'm sort of conscious that I'm probably talking quite a lot. So that's how we taste, through nose, microbiome, and all our receptors, and we pick up on all these nutrients in that experience of tasting. And so I'm developing now projects that look at this relationship between the Brix value and taste testing. And where I've begun with this is break down the barriers in trusting ourselves to know what taste is by creating these 4 metrics that I believe relate to the quality of the soil, the plant, the seed, and our gut microbiome. And I can talk to people about this, about water balance relating to the health of the soil. So if it's watery, it's an indicator that it's not very good. If it's balanced, it's an indicator that it is. Sweetness relates to this symbiotic relationship with the plant to produce carbohydrate. When it's in symbiosis, it's more sugar. So most of us can detect water and sweetness, so we're halfway there. Flavor is about the complexity when that plant goes into symbiosis. And the aftertaste is about our gut microbiome sensing what's in the food. So when you consider all those factors, you can either then say, I think that one's best, or you can mark it on a 1 to 9 scale, a hedonic scale. And this is the results of marking it on a hedonic scale that I did at RAU actually last year. So it's starting to show this relationship between our sense and taste and the Brix value. So in developing the food quality standard database, citizen science, I am suggesting these are our plant quality metrics that we can measure. And when you add all those up, that equals food quality. So if you start to see all those metrics registering, as a high value, then that's pointing us towards, I think, high quality food. And it's the farmer and grower who can do this at source, and it's the food citizens who can come along and verify it with a comparative taste testing session. I've just now started a project with the Andhra Pradesh Community Natural Farmers. Back in December, they got back in touch and said they'd like to do some more work. And so I put forward this proposal as a 3-step plan, which begins with a pilot to explore this relationship between Brix and taste. And the problem that I've always had is, how do you identify high quality, low quality food? So when it goes into laboratory analysis, you've got a marker of what you're actually looking at. So step 1 was to run that pilot. Step 2 is to scale that up. If it works, scale that up, and let's do 1,000 taste testings. And every time we get one session where chemically grown food and naturally farmed food are assessed, so I've got 2 samples of each, where we find the highest Brix value correlating with the highest number of taste preferences, I'm calling that high quality, and the lowest Brix value and the lowest number of taste preferences, that's low quality. So that's how I'm marking high and low quality. So we'll scale that up, and where we find those 2 examples, those crops plus the soils they're grown in, I'll send for nutrient analysis and soil health indicators. So now we've got a relationship between a marker and the actual composition of the soil and the crops. And then step 3 is to run clinical trials for 6 months, feeding group A, what we're calling low quality, and group B, high quality, to measure health outcomes. So if you can show over 6 months that eating a diet of high quality food reverses or makes you better from obesity, diabetes, possibly cancers, heart disease, mental health, then it's beginning my hypothesis begins to stand, that we've got this innate ability to know what is good for us. And that also supports the development of the food quality database, because you've now got a system of actually identifying the food that makes it good for us. So this is what I did when I went to, so it's about 4 or 5 weeks ago that I started the project, went out to India. We sampled 50 farms to create a baseline. So, and 327 crops were Brix tested, ×3 each one to give us a good average. And then we ran 16 comparative taste testing sessions with those crops with 350 people, men, women and children. Oh, okay.
Make it a bit smaller and then it will move.
Did I do something like that? Yeah. So we went out into the villages and ran the comparative taste testing sessions. They didn't understand, first of all, the concept of a blind study, so I had to guide them a little bit. So this is now, I'm happy that the way this taste testing was done was in a blind situation. And so we told them about the food quality metrics, but then just asked them to taste the 4 samples and just point to which one they liked best. And the recorder would then record which one. And so what we're seeing here on the graph below is a relationship where it's green. It had the highest Brix value and the highest number of taste preferences. And here in red, it had the lowest Brix value and the lowest number of taste preferences. So this is what I'm now marking to call high quality, low quality. So that was tomatoes, that was sapota, this is guava. And so it's beginning to work. I'm seeing this relationship between the Brix value and taste testing preferences. This is that taste testing broken down. So of the 4 samples, 2 are chemically farmed, 2 are naturally farmed. Here are the Brix values. So the highest one of 12.3, 9 children, 17 women and 8 men, making a total of 34, all independently agreed that that had the best taste. And the lowest Brix value, which was chemically farmed, only scored 4. So with that amount of confirmation, I'm sort of quite happy to place the tag. I think this is high quality and low quality. That's a summary of the overall pilot project, showing lowest Brix value, highest Brix value, and according to Ream's table, where that fits. So actually, I only found 1 beetroot that had excellent value, and all the rest had kind of average to good values, suggesting that actually their quality could still be improved.
Just checking the time.
Yeah, I know. So a farmer record, once you create a farmer record, farmers can compare against other farmers. This is a relationship between indigenous seed and hybrid seed based on Brix values alone. So the 4 highest values relate to Desi seed, which is local indigenous open pollinated seed. And then we've got 1, 2, 3 samples of hybrid seed, which all produce low Brix values. So already this is pointing to something that could be really interesting about seed quality. And as we build more data, we'll find out. That's just the range of Brix values for aubergine, because we don't have an indication of poor, average, good and excellent, but we could work that out with developing this work. Brix over time, so I'm just going to move on, but you can start to see that it gives you a lot of feedback loops. And this comes out of the results from doing the testing in Wales, the beginning of the database. These are all local growers and some shops, Lidl, Tesco, for tomato values. So you measure their crop, you put it into the poor, average, good and excellent column, and then suddenly you come across something that is so good that it hits the top of the table. So the salad tomatoes and the cherry tomatoes grown by Shume Natural Agriculture all had the highest value. So suddenly that sits at the top of the food quality table, suggesting it might validate this method of growing their food. And the way Shume grow their food is unconventional to what we're used to. So this is GrFFN trying to create membership strategy platform for growers to join. So we're into growing at the moment. You buy yourself a Brix kit. You then enter your values through the database. And then we start to see, so this is a summary of other ways to grow food that are not conventional, that might involve a kind of consciousness, spiritual-based practice. So we've got Sure Natural Agriculture, and here's my finding of their quality of tomatoes sitting at the top of the table, begins to validate their methods. We've got biodynamic, that's where I learned about measuring food quality using chromatography and things, and there's, you know, interest there. And then there's the Brahmakumarish yogic farmers in Rajasthan, India, who I also went to visit when I was there. And one study done by a professor in South Africa, who I think you know, Julia, showing how meditation has an effect on plant growth. So this is a consciousness practice affecting the quality of the plant. So these are all interesting, pushing the boundaries kind of ways of thinking to grow food that developing a food quality standard database could start to validate. And there we go. Thank you very much.
Thank you very much, Matt. And we've just got to try and stop the recording now as instructed.
Oh, yes.
And just, but that was, I think it was amazing. And I mean, I think, you know, we have here at CORE, we had a new research cluster on agroecology and health. And I think this almost kind of provides a justification for it and a lot of the indications of where we can do more research. You know, I mean, you've done an amazing amount yourself, and I think it kind of is quite inspirational. So I'm just taking try and stop the recording, and then you know, questions, please. I don't know who wants to start. Yeah, well, but what?
Rachel.
Leo, come here. But anyway, does anyone here have a question, or I mean, to start with, and also online, when we get your pictures up, we text and get your pictures up. Yeah, we want to we just want to stop sharing, and there's the recording button. Yeah, let's see if that works. Now, so now we can see everyone online. Thanks for listening. So does anyone online, if you do have a question, just raise your yellow hand and we can see it. And anyone here in the room as well. Yes, please.
I think I have a comment, because you say, for example, in the part that you say the farm from US and farm from UK, they are different in terms of the nutrient density. Yeah, but I'm thinking this also is related with the soil composition and also with the environment, because there is a very high relationship between genotype, environment,